currents will be formed.
Okay, eddy current. इसको मैं बड़ा कर देता हूँ. Instead of this profile, ऐसे कर दिया हमने. Shape तो आप देखो आगे से पीछे same थोड़ी होती है. So this also I am reducing it, but still it will be there. Technically yes, but because of this knowledge only we are profiling in such a fashion that the resistance is as small as residual resistance is as small as possible. Now since it is the sum of the two, if you will find that for slow speed vessels, residual resistance may be only 5% of the total resistance. But as for the vessels which are moving at greater speed, this may be almost 50 to 60%. Fast moving vehicles, the residual resistance component is almost 50 to 60% of the total resistance. Therefore, it becomes important for fast moving vehicles or vessels that residual resistance has to also be taken care of. And that is why the bulbous bow. Otherwise, bulbous bow, if I am making, I am increasing the wetted surface area, and therefore I am increasing the frictional resistance. But since it helps in reducing the wave making resistance, and that is why we are using it. So if the vessel is moving slowly, in fact I am increasing the frictional resistance. So bulbous bow has no use, rather it is increasing the frictional resistance and the total gas resistance. This is just to illustrate change of cross section. Anywhere, even if it need not be abrupt, but as long as there is a change of cross section, the waves cannot move smoothly, which they would be if the whole thing is streamlined. Same thing is true for aircraft also. That is why we say aerofoil structure and all. This is only streamlining because their air is moving, here the water waves are. So this is the total resistance of the vessel. Now, as I told you, for actual calculation for a particular vessel, this total resistance is the one which is calculated. Now, this part of calculation is not in your scope, so I am not going into details of how actually it is done, but actually it is done with the calculating frictional resistance and residual resistance for prototype model, and then we have formula of corresponding speeds and dimensions to calculate what will be the total resistance of the vessel. However, they said we can calculate approximately the power required using what is known as admiralty coefficient. Under admiralty coefficient,
बिजी है लाइन यार कब से सुबह बात होगी वही है पता नहीं वो उधर से बोलता है मेरे उसकी अब तक करवाता हूँ मैं देखता हूँ कुछ कर तो आने वाला
So here they have made an assumption for small changes in V, what is V? Speed of the vessel. We can say total resistance of the vessel is proportional to rho S V raised to power n. And who said this? Mr. Wayne Froud. Froud is a, you must have used Froud formulas in naval art. Yes or no? Very awesome. Wayne Froud has given us a lot of formulas, just like Newton is so famous for giving us. Similarly, in shipping industry, a lot of formulas have been given on basis of extensive experiments, and they have found, and they have, by application, it has been found they are truly representing the particular parameter. So, total resistance can be said to be proportional to rho into S into V. That means the density of the water. S is rho is the density. S is the wetted surface area V is the speed of the vessel, area in meter square, speed of vessel in knots, and N is a index. N is the index. Now the value of this index depends on the speed of the vessel. Whether the vessel is slow speed, medium speed or high speed. Normally, for slow speed, the value of N is 1.825. We approximately take it for slow speed vessel as 2. So for our purposes, we will take value of N as 2. Okay. Model 1.825, approximately 2 for slow speed vessel.
स्लो स्पीड
हमारी स्लो स्पीड है
हम 2 लें.
लिमिट क्या है?
It varies from 1.8 to approximately 4.5. And there is a method of calculation, but we will not go into because our interest is to solve the numericals which are coming in exam, not so much going into the theory how it is done, but I am giving you some idea so that we exactly are not absolutely doing the numerical blindly. We must have some background as well.
1.8 से लेके 5 तक है. 2 तक है.
This is for slow speed we are taking as 2.
2.
Approximate का sign है.
हाँ.
चलो यार इसको यार 1.8 to 5 नहीं क्यों confuse 2. Okay. For slow speed
or 2.
take the value. पंगा ही खत्म करो. काहे का confuse हो गया. अगर दिया है न्यूमेरिकल में वैल्यू है नहीं so much then we have to take that value. Otherwise we take it 2. आपके 2 ही आएगा ज़्यादा. आपको जरूरत नहीं पड़ेगी.
हमने अपने स्कोप के बाहर जाना ही नहीं है.
हाँ इसीलिए मैं I was hesitant in giving this value.
बाकी बड़ा सब है जहाँ.
हाँ ना.
बाकी बड़ा सब.
बड़ा देखिए होगी. ये different. We have to first see whether the vessel is. उसका भी एक फार्मूला है. ऐसी बात नहीं है. फार्मूला है. Equal to हाँ.
इंडेक्स का मतलब इंडेक्स
And
हाँ
N is
इंडेक्स
the
इंडेक्स रेस टू द पावर.
अभी के लिए 2 ठीक है.
V
अभी
square.
आगे don't jump to conclusions. Now we come here.
बाकी कहीं भी गलत.
Root of resistance is equal to rho s Bn. अभी 3 लाइन्स में एडमिरल्टी कोएफिशिएंट का फार्मूला आ जाएगा इन 3 स्टेप्स और एट द मोस्ट 4 स्टेप्स. बिकॉज अगर आपने देखा होगा फैब्री में पूछा है व्हाट इज दिस कोएफिशिएंट, एक पूरा क्वेश्चन है डेफिनेशंस का. सो यू कैन राइट दोज 3 लाइन्स एंड दैट शुड बी द आंसर. नाउ हियर wetted surface area S is area. What is the unit of area? Meter square. That means L multiply by N. So I can say S is proportional to L square. Yes or no? Because S represents the area. It is a square of a dimension. Linear dimension का square है ना. अगर 4 meters है तो 2 का square हो गया. जितना भी हो, it will be square of something. So it will be square of a linear dimension. Delta. Delta is the displacement, which is cube of a linear dimension. And therefore, pardon? ये तो normal common sense है ना? Any area is, this is called dimensional analysis, where area will be always, you can always calculate a linear dimension जिसका square है वो है ना. Even if the area is 4.5, you can find the what is the value of that linear dimension जिसका square वो आएगा 4.5. Yes or no? So we can write area
Square of the linear dimension.
Square of a linear dimension. What is the value of n? You cannot say क्योंकि हमने अभी कुछ डाली नहीं है value. Similarly, displacement is the cube of linear dimension, and therefore we can say from this one, this is 1, this is 2. From 2, we can say L is proportional to displacement raised to power 1 by 3. Can we say or not?
कह सकते हैं.
If delta is proportional to L cube, then L is proportional to delta cube root or delta raised to power 1 by 3. And if I put the value of L in 1, I can say S is proportional to delta raised to power 2 by 3. Yes or no? If L is proportional to, without changing the proportionality sign, I can say S is proportional to L की जगह मैंने डाल दिया delta raised to power 1 by 3 और ये L का स्क्वायर था ही था, so delta raised to power 2 by 3 हो गया कि नहीं हो गया? हो गया ना? Therefore RT is proportional to rho S. S is delta raised to power 2 by 3 into V raised to power n. Now power. Power is always proportional to RT into V. सबको V है ये, everything here. This is also V. This is also. Power is always why power is proportional to RT into V? Because RT is a force, and what is speed? If I convert into meters per second, so this will be force, that is Newton and meter per second, that is power. हमने पहले शुरू में बोला rate of doing work is power. Therefore power is proportional to RT into V, and therefore power is proportional to RT is this into RT is this much, we have calculated already, it's 14 there as well. So rho delta 2 by 3 into V raised to power n plus 1. कह सकते हैं ना? अच्छा यहाँ ऊपर लिख देते हैं. Maybe you are not able to see.
नहीं, हाँ, जाना है ना, उसके बाद ही मिलेगी.
Power
नहीं करा सकते और दे सकते हो.
is proportional to RT into V is proportional to RT is rho delta V delta raised to power 2 by 3 into V raised to power n into V is proportional to rho delta 2 by 3 into V raised to power n plus 1. Yes or no? Now, if I remove sign of proportionality, then I can introduce a constant. Yes? Now, I am assuming density of the seawater to be fairly constant. So, rho is also absorbed in that constant. V. V is the speed. Yes.
वो नीचे क्या लिखा डेंसिटी
जून में आएंगे.
सर वो नीचे क्या लिखा
RT की जगह लिखा है rho delta raised to power 2 by 3 into V raised to power n into V.
तो वो सेम चीज ऊपर
सेम चीज लिख दी, वहाँ नीचे पढ़ा नहीं जा रहा था लोगों से, शायद पीछे से शायद हो. And therefore, if I remove this and incorporate in a constant,
दो भी है
then I can say a constant is equal to, and I am removing the sign of proportionality,
नहीं
delta 2 by 3 into V raised to power n plus 1 divided by power.
डिस्प्लेसमेंट
AC is that fertility coefficient. It's a constant.
फॉर्मूला गायब हो रहा है.
So when I remove a sign of proportionality, I have to incorporate a constant. Then only I can remove. Taking value of n taking n is equal to 2 for slow speed vessels. For slow speed vessel, AC is equal to delta 2 by 3 into V cube divided by power. This is the formula for admiralty coefficient. Once you go through it again, you can do it in 3 steps only. Although I had taken more steps just for mechanics. Delta is the displacement of the vessel. Pardon? What is the difference between volume of displacement and displacement? Only density. Density is there in the constant. कोई बात नहीं, अब ले लो. You are adding row and then removing row. यही तो बात है ना. It is same thing. You can add it.
speed.
सर उसको वॉल्यूम लेना है डिस्प्लेसमेंट लेना है.
Displacement in tons. Delta is displacement in ton.
सर ये छोटा भी है सर ये.
छोटा नहीं है यार, ये बड़ा ही है सारा.
तो
All are big को मेरे लिखने में थोड़ा हो गया. This is V. बड़ा V, capital V. वहाँ नहीं, he is right because please remember whenever we use capital V. नहीं, it is
पर एक चीज था तो यहाँ पे प्रोपोर्शनैलिटी को हटाने के लिए कांस्टेंट क्या था?
AC यही तो कांस्टेंट है.
जो ऊपर पावर चल रहा है. ओके सॉरी.
पावर करेंगे सर V को पावर
AC is admiralty coefficient.
सर V को कन्वर्ट करना है या नॉट से मीटर में.
अभी नहीं करना पड़ेगा कभी. तो हम तब करेंगे. तब हम कैपिटल V ये नॉट्स and small v is in meters per second. ठीक है, जहाँ small v लिखेंगे वहाँ v is in
मीटर पर सेकंड.
मीटर पर सेकंड. चलो यार मैं इसको और बड़ा कर देता हूँ. थोड़ा कंफ्यूज हो रहा है जबकि कुछ है नहीं. अभी यहाँ तक ठीक है. नहीं यहाँ तक ठीक है, मैंने बताओ. यहाँ तक ठीक है. अभी ठीक है, यहाँ तक ठीक है. ओके
सर आप सीधा फॉर्मूला दे दीजिए.
पावर
बात ही खत्म सर.
इज प्रोपोर्शनल टू रो इनटू डेल्टा रेज़ टू 2 by 3 into v. यहाँ तक ठीक है.
यस सर.
Therefore is proportional to rho delta 2 by 3 into v raised to power 3. यहाँ भी ठीक है. n taking n is 2. Okay. Therefore power is equal to a constant k. अगर प्रोपोर्शनल डिजाइन निकाल दिया k into rho into delta 2 by 3 into v cube. अभी भी ठीक है.
यस सर.
अब ये सब कांस्टेंट इधर ले आओ.
ठीक है.
Therefore 1 upon k into rho is equal to delta 2 by 3 into v cube divided by power.
हाँ अब आया.
इसको मैंने कांस्टेंट कर दिया है because rho is constant, k is also constant. इसको बन गया admiralty coefficient is equal to
रो है डेंसिटी
over power